Okay, it is good to see that I do not know everybody in the room. So let me start with a couple of questions to you. So by show of hands, how many of you what Nephio is? Tal, you have to, Bim, you have to. Okay, that's good. How many of you know that what are the ideas behind Nephio? What are the good new concepts? How is it different from other network automation approaches? Wim, you also have to. So, okay, less people, actually less than I thought. How many of you think that it would be a good idea to use Nephio in production right now? I agree. I agree with this. And after we, as the Nephio community, came out with Nephio Release 1, it was obvious that we still have a long way to go. The current implementation is not ready to handle a real production complex system like a 5G core. But I wanted to know how far are we, what are the gaps, and how to fill them. So basically, I set out a journey that I want to share to you right now. And what I did is that I took an actual Nokia product that involved a real-world 5G core, and I tried to replicate that setup with Nephio. And let's see, I thought that let's see, can I do it? What will be missing? What do I have to implement to do that? But before I go into the details of that, that is what I will talk about today, mainly. Let's talk a couple of words about the setup that I try to recreate. So, as I said, it's a 5G core. It is part of an actual thing that you can buy from Nokia right now. So it is not a theoretical setup. It is not a proof of concept. It is the real deal. It is already was designed to be deployed into one of the big public cloud providers, more precisely into Kubernetes clusters into a public cloud. The cloud resources that are required for this whole thing to work, to host all the infrastructure elements that is needed, this 5G core to work, were managed by Crossplane, something called Crossplane. That means that the infrastructure was already managed by Kubernetes resources. Very good if you want to automate something with Nephio. The network function instances themselves, the lifecycle of them was already managed also by Crossplane. Again, that means that it was managed by Kubernetes objects in a Kubernetes native way. So it was a very good, really cloud native starting point. What could go wrong? It seems to be easy. It turned out that this is this typical famous last word scenarios. So this product also came, finally this product also came with its own opinionated way to deploy things. I would call this a deployment strategy. In this case, that means that the whole complex topology was deployed into one and only one workload cluster, but dedicated node groups were created for each and every network function instance. Even more, each and every network function instance was typically deployed into multiple dedicated node groups. The whole thing was connected by subnets in a single VPC. That's it. So that was the deployment strategy that I also tried to recreate. As expected, I encountered some challenges in the way, and these are the ones that I try to list here. First of all, even though I already had custom resources to deploy these network function instances, in order to make it Nephio compatible, I had to use something that we call a network function blueprint in Nephio. And again, it seemed easy. You just shove it into a capped package, into a so-called capped package. It will be easy. Again, famous last words. It turned out that I had to add 2 more kinds of things besides that to the network function blueprint. You will see later that what those are. Neither of them turned out to be easy. I also had to have a way to describe this complex topology of instances and networks. And we already, again, seemed easy. We already had this concept in Nephio. I only had to reuse them, and I did. I reused the network function topology concept of Nephio. I only had to make small changes here, to be honest. Third, what I wanted to do is really to do this one-click deployment, really to automate the lifecycle management and the infrastructure management of this particular 5G core that I selected. And I really wanted to achieve this one-click deployment as much as it is possible. In order to do that, I had to add a big feature for Nephio that is already talked about, but it is not part of Nephio Release 2 yet. And that is to automatically calculate the necessary changes in the infrastructure to host the newly deployed network function topology, or to host the changes that were made recently in the topology. In order to do that, I also had to do a lot of things just in order to achieve this. I had to have a way to describe the infrastructure requirements of network functions. I had to add an abstract description of these requirements to the network function blueprints. Remember, this is the first thing that wasn't obvious that I will have to add to the NF blueprints besides the custom resources. I also needed to know what is the current state of the infrastructure. Because even though if I can calculate the desired state of the infrastructure, I have to compare it somewhere to the current state and basically calculate the difference. And if you remember the deployment strategy that I described, that would mean that I also had to introduce the concept of node groups that I called node sets, because it is more the Kubernetes way of calling things. I had to introduce that new concept that wasn't part of Nephio so far. The third thing is that I had to provision the infrastructure. OK, I calculated the desired state of the infrastructure. Now I have to actually deploy it, provision it. Again, I already had cross-plane resources at the starting point. What could go wrong? It is easy. The problem was that right now, Nephio is built in a way that the workload clusters are managed by cluster API, and the workload clusters are kind clusters. And I needed to add a way so that Nephio can host multiple infrastructure providers at the same time, and you can select which one to use for your deployment, maybe multiple ones. So the deployment strategy should be able to select between multiple infrastructure providers. Again, you will see how I solve this problem. And finally, after the infrastructure deployed, I had to deploy the network function instances. For this really wasn't a challenge. I used the same technique that we are using in Nephio. Anyway, I used Porch and package variants to do this. The only thing that I had to add, the second thing I had to add to the network function blueprints, was the capability to inject pieces of information, data about the current state of the infrastructure, namely the target cluster, information about the target cluster, where the network functions will be deployed, the information about the node sets, where the network function will be deployed, and to create an automated way to distribute this information and reconfigure the actual custom resources belonging to the workloads of the network function instance. Again, there is a standard way in Nephio how to do that, and I didn't change that. It just had to be done. OK, there are some non-goals here. I deliberately didn't touch configuration management. If you remember, I deliberately said infrastructure and lifecycle management. For configuration management, please see Wim's future presentation. Same goes to resolving package dependencies across packages. And I also, for expressing the infrastructure requirements, I went with a simplest solution that was still viable. OK, so first let me give you a very quick overview of the process that I came up with. And then I will go into the details, into the important steps. So after this quick overview, it is normal if you will have a lot of questions. If you still have questions after I went into details, please ask me at the end. So the very high-level overview of what I did. We start with the catalog that contains these blueprints that I've already mentioned multiple times. Then we somehow create a so-called topology that describes the instances of these network function blueprints and also the logical network connections between them. And in order to trigger the deployment of this topology that we defined, and by the way, I try to keep this topology description as target environment agnostic as it is possible. So theoretically, you can deploy the same 5G core that was designed by some network engineers into multiple kinds of infrastructures following multiple kinds of deployment strategies. But in this case, I triggered the deployment by creating a custom resource in the management cluster. And that is the kind of this resource is Nokia deployment. I call this kind Nokia deployment because the corresponding controller, the controller that circle there tries to represent the controller for this Nokia deployment kind of resources. That is the part that implements this deployment strategy that I described to you in the beginning. One cluster, multiple dedicated node groups. And then what the controller will do, it will read the topology, it will read the current state of the infrastructure from the inventory. Disclaimer there, inventory might be a bad word here. It might be a misnomer. I will define later what I mean by inventory in this context. It might not be the same as you think of as an inventory right now. So the controller for this Nokia deployment strategy calculates the necessary changes of this infrastructure and creates a bunch of Kubernetes resources in the management clusters. And these resources are claims for various infrastructure elements. And these claims contain requirements toward these infrastructure elements. I will go into details of that. Then somehow a controller will be selected for each and every one of these claims. And I use the word selected deliberately. And that controller that we selected will do two things. One, it will create a Kubernetes resource that will manage and create the actual cloud resource eventually in the public cloud. I've already told you that I used Crossplane for that because that is what I had at the beginning. And the second thing it does, it creates or updates items in the inventory to describe the newly created or updated elements of the infrastructure. You can see that it will result in creating the workload cluster and maybe multiple node groups in that workload cluster. And basically the final step is to deploying the packages in the newly provisioned cluster and node groups. I do it in a Nephio way, and that is that basically I take the corresponding network function blueprints, clone it, and specialize it. And by specializing, I mean that I will turn them into so-called deployment packages that will contain configuration that is specific for that particular 5G core instance. And more importantly, it will contain configuration that is specific to the target cloud, to the target Kubernetes cluster, and to the target node groups that the network function will be deployed. How I achieve this? By injecting this configuration data that I mentioned, basically the same controller, the same porch that we use for here is also able to do this kind of variations, introduce this kind of variation in the package, and inject the inventory items, the related corresponding inventory items into each and every network function package. So at first it looks more complicated than it has to be. And it would be fair to say that, oh, that is really complicated, why is that? Well, there are multiple reasons for that. One is just in order to solve those challenges that I listed in the beginning requires this. For example, I want to use cross-plane instead of the cluster API for deploying the infrastructure. I had to introduce a way to replace that in Nephio. The other way for the complications is that I wanted to solve these problems in a way that is a step toward making Nephio, sorry. That is a step toward making Nephio into a general purpose automation tool, and not just a POC for a specific use cases. And that also introduced some complexity here. And the third reason is that I imagine that, and we in the Nephio community imagine that in the real world there will be multiple personas that all of them wants to fulfill their role in this process, and we have to give them opportunities, entry points, connection points to them to do their job in this process, like the network function R&D who knows what the infrastructure requirements are, and they should put it into the blueprint, and they know how to configure their own network function based on the information regarding the target cluster. So they will put this into the blueprint and create and publish this blueprint. I strongly believe that the topology will be created as a collaboration of human network engineers who know how to build a 5G core out of these elements and automated processes together. And of course, there are these platform engineers, SRE engineers that will manage the deployment part, that are already managing the infrastructure, know which kind of infrastructure provider they should select. Maybe they even participate in writing the infrastructure provider for their particular infrastructure. So these are the reasons for this complexity. Okay, I can see that I have limited time by now, so I have some insights, or I wanted to dig into most steps, but right now I will skip to the infrastructure provisioning part, because that is the part that I think is important. So very quickly, you can read the slides later. Of course, they will be shared. We already talked about the blueprint. It contains the injection points and the infrastructure requirement parts. The only thing to note here, maybe, is that these infrastructure requirements in the blueprints are expressed via the same claims that you have already seen that were the output of the deployment strategy. For example, there is an example there for a node set claim that states some requirements towards the nodes. Should it have DPDK? Should it have different kernel modules deployed? Things like that. And what the deployment strategy will do is to take all of these claims and calculate a summarized set of claims from all of this in the topologies and in the blueprint packages. Topology package, we also talked about. One thing to note here very quickly is that I use the package instead of a Kubernetes resource, that we are using right now in Nephio. One of the reasons for that is that in the current state of the implementation, for this whole thing to work, it requires a manual hydration for the topology package in this case. That is basically just a fancy way of saying that you have to manually add data to the topology and push it into Git manually again for the next steps to work. But I also think that it is the right way to go because of the reasons that I already existed. Okay, inventory, I don't want to talk about is the inventory only stores is just a database. Right now, I'm using the etcd and I'm storing resources in it, but these resources are not like Kubernetes resources. They are not intense. They do not have a spec and a status. I only have them a data field to emphasize that this is just information that we store. And there are multiple ways to manage the items in the inventory. I do not have the time to go into that. One thing to keep in mind is that so I suggest to keep these information records, inventory items, separate from the resources that will actually manage the life cycle of this infrastructure element, like the give me a cluster resource shouldn't be an inventory item, because not every piece of infrastructure that Nephio wants to know about will be managed by Nephio. So we may want to deploy things for Kubernetes clusters that weren't created by Nephio, for example. And now we arrived to the infrastructure provisioning part. And that is the last thing I will go into detail with, and then I will try to summarize. So, infrastructure provisioning, already we start with blueprints, with the claims, and the topology, and the inventory. When we create this Nokia deployment resource, of course it has a reference to the topology that you want to be deployed, but it also has fields that is required, for example, to create the workload cluster if it hasn't been created yet, reference to the Git repo, that is the deployment repo for the workload clusters, and things like that. What it will do, we already seen. First, it will gather information from the topology and the inventory, and it will create these infrastructure claims. The example here is the cluster claim example, and there are two things to note here. One thing is this class field of this claim. Class field is used exactly the same way how storage class is used with PVCs, or ingress class is used with ingress, or the recently introduced gateway API use classes and claims and classes and providers. So it's a well-known pattern in Kubernetes that I'm trying to apply here. So basically, the class here will select the provider that should be used to actuate this cluster claim. It can be something like an AWS provisioning via crossplane. In the case of current Nephio, it would be something like a kind cluster via the cluster API, but it can be anything like a GKA cluster via Google's own config connector classes. It can be anything, basically. And the second thing to note is also something that we are already using in Nephio, but not for infrastructure management, is that we call parameter refs. In order to give class-specific configuration data to these claims, I used something called a parameter ref that is basically allows me to add arbitrary Kubernetes resources, to attach arbitrary Kubernetes resources to this claim. The only difference that I did it in line instead of just referencing other resources. And of course, then, based on the class, a controller will be selected, and that controller, in our case, will create the crossplane resources for creating EKS clusters, subnets, routing tables, anything that is necessary. And it will also update the inventory. We already talked about that. OK, summary. So two things. One is the diff to the current state. Basically, the diff of what I showed you and Nephio Release 2. One of the major features that I had to add in order to be able to recreate this setup was this automatic calculation of automated infrastructure provisioning. Good news, of course, that the Nephio community is already working on that. And in order to add that, I also had to add a lot of other features that are listed here. I already talked about that. The other thing that was sorely missing and I had to add is to ramp up, to step up with the infrastructure, the vendor-independent infrastructure management, and I applied this claim class provider pattern for that. Less important, but I also made some changes for the topology. OK. These are the conclusions. Perfect. I'm about to finish, so it is perfect timing. So some conclusions. These are not really OK. So what I set out to do was a proof of concept. Basically, I want to prove that the concept of Nephio works. As expected, there were gaps in the implementation. We know that when we released Release 1 or Release 2, not much surprises there. Disclaimer that I filled those gaps, but the Nephio community most probably will come up with something different to fill all those gaps. But of course, both my experience and the code that I wrote will be contributed back to the upstream project. OK, so just to summarize, and this is really the closing thought, that I know that there will be gaps in the implementation, and there were. However, I hope that the Nephio community would agree that how I filled those gaps closely followed the principles, the ideas, the concepts behind Nephio. And based on this, I would say that it works as a proof of concept. And I really think that the concept and the principles behind Nephio are not just work in a real-world scenario. I also think that they are a little bit ahead of not just the state of automation in the telco industry, but also the state of automation in the Kubernetes ecosystem, in the Kubernetes community as well. So if it is possible, I believe even more stronger in the concepts and the principles of Nephio. And as I already told you, most of the gaps that I talked here are being already worked on by the community. So that is my message to the Nephio community, to myself as well, is to keep up the good work. I think we are on the good track. We just have to deliver the promise. Thank you. That's it. And of course, if you have any questions, then go on. So I will try to summarize that. I will not try to repeat everything you said, but I think the question at the end was that aside from all the infrastructure management that I showed, and this was really a big part of this presentation, how well are we fare as the Nephio community in actually deploying the workload onto the infrastructure that, for example, we have we know about the infrastructure, even if it is not managed by Nephio, via this, what I call the inventory. Yes, as I told you, for the deployment, that was the easiest part. In the beginning, in the challenges, I told you that this wasn't really a challenge. I used Porch, I used the hydration process that I didn't have time to go into details right now, and I basically used this inventory to inject the inventory elements, and it worked. So I would say, again, and this is the part, by the way, this is the part where when I'm saying that we are a little bit ahead of the current state of the art, this is the part mainly that I think about. Not the infrastructure management part, because it is not really covered yet, but how we deploy, how we go from network function blueprint toward the deployment package, and that the notion, so I would think that is the strength of the current Nephio implementation, to answer your question without going into detail. Okay. I think we do not have any time, but we do not have any questions either. So, OK, thank you very much again.